Howdy, I'm John Richmond, and I'm the inventor of the Sluice Goose GOLDROP, gold and Paydirt separating processor. Today's video is a further demonstration of how well the GOLDROP can separate mercury from soil. Mercury has a density of 13.5 grams per cubic centimeter, much lighter than gold at 19.3 grams per cubic centimeter. We've already established a rate of recovery of the GOLDROP for gold at 99% plus. This video will establish a rate of recovery of mercury, a much less dense metal, from soil. So what I should be doing is digging up some soil from outside, contaminating that soil with this mercury, and then processing and extracting this mercury, hopefully all of it, but probably not. But we'll see what percentage is recovered by the GOLDROP. This is the area that I shall dig in order to collect my samples of the dirt that I'm going to process through the GOLDROP to remove the mercury. You can see there's a lot of clay deposit there, all crackling. It just rained also, so it's just now a half hour old. This is the dirt that I dug up outside in that spot. It's been oven dried, 350 degrees for 2 hours. So now we're screening it through the sieve. It's number 6.132 opening size. And as you can see, organic materials in there, leaves, stems, grass, just all sorts of different materials. So, see what we got underneath here. This is the consistency of the material after we've screened it. So pretty clean dirt it looks like, but it's just not dirt, it's clay. Nice clumpy clay. So we'll run this through the GOLDROP. This is the mercury we're going to add to that soil. See how much we have here. "40 grams is the amount of mercury that we'll start with. So we'll take this mercury and we'll add it to that dirt, and we'll see how well the GOLDROP can remove this mercury. I guess I sneezed too hard. This is the dirt we're going to add the mercury to make our mercury dirt blend. So what I shall do, I'll be dropping the mercury through this screen here. This is a 2mm screen. So that way when the mercury hits the screen, it'll disperse through and hit the soil in different places. So I've cut the bottom out of a bucket here, kind of a splash guard, so nothing ricochets out of the screen. And let's go ahead and see what happens here. Well, there's all of our mercury in the soil. Well, I'm not sure if you can see any of it at all. Well, I guess you can see it peppered in the soil there. Well, we know it's in there, so now I'll go ahead and dump the rest of the soil in on top of it. And there we have 44 pounds of soil, and now we're going to see how clumpy it is, clay. It's pretty clumpy that way, but that's dry. That was in the oven at 350 degrees for 2 hours. So now we'll screw on the lid here. There we go. And I'll chuck that in the lathe and tumble it. We'll give the dirt a 10-minute tumble. It's 30 RPM. That should give us a pretty good blending of the mercury into the soil. This is the Sluice Goose GOLDROP, gold and Paydirt separating processor. Today we are testing to be a mercury and Paydirt processor. Or separating processor. So we're going to try to separate mercury out of soil. The GOLDROP operates on a recirculatory system. The water is pumped out of this barrel here by this 12-volt, 1100 gallon per hour bilge pump through the manifold here and through the GOLDROP through the various lines. So the water then discharges out this line here and into the tailings bucket. So the tailings bucket is supported by this frame here in the tailings barrel. The water fills the bucket with the tailings from the GOLDROP. The water then overflows into the tailings barrel. This water then is siphon fed over to this reservoir here, which then, as the dirty water travels to this barrel here, the dirt has the ability to settle out into this barrel before the water then transfers again by means of gravity into this settlement barrel, and then from this settlement barrel back to the pump barrel. So the water here is as clean as it possibly can be through the settlement of 3 additional settlement tanks. So the water here now is definitely minus any of the solids that would damage the pump in the process of running the GOLDROP. This is the procedure I use for feeding this Paydirt through the GOLDROP. This here is our Paydirt that we've classified and blended the mercury into. So what I've done to feed it through is I've liquefied and made it into kind of a slurry muck. Let me get it around so you can kind of see this here. Very soupy. It begins the fluidization process and allows the dirt to easily run through the gold drop. So my procedure is take a scoop of this and then to put it into the funnel. I've got the scoop inverted. This material is so much clay that it really likes to cling, as you can see. It resists movement. So for that reason, that's why I've made it really soupy. So that when I dump it in, that it'll at least semi-flow into the funnel. So I have this water flow on the other side, which is then eroding the slurry down in through the feed tube where the material drops into the trap. And I'll show you the trap here. This is where all of the material feeds to. You can see the action inside the trap, how it's in constant movement. And you can actually see the mercury kind of dancing around in the funnel trap. Now this is the point of elutriation. This is where the heavy materials drop out and drop down through the elutriation tube and then into the jar. So we are collecting all the heavy material, including the mercury, in the jar. So the action by all of this water converging at this point here this is what's happening inside the trap, inside the column. All the material, let me get to the other side, it'd be better. You can see the movement of all the material in the trap is under constant movement, up and down, and a continuous wash. A little mud smear on the outside. But this is what allows all of the heavies to accumulate down here at the trap and the opportunity to fall down into the jar. So our current drop water setting, we're basically right at 0.2 gallons a minute. So our total consumption of water right now with the drop water, and this is the spin, or the trap water here, which is creating that disturbance right there in the trap. And then the feed water is less than a gallon a minute, causing all of this disturbance. And then as the material leaves discharge into the tailings bucket, that's our water flow. Very little. Not enough to raise the material in the trap out into the tailings. So the flow of material through the GOLDROP happens because the action on the fluidized dirt entering into the feed tube and down into the trap happens at an elevation which is greater than the discharge. So the water has a natural path to leave the GOLDROP purely by gravity. And then the water flow that you engage actually controls the rate at which the fluidized Paydirt travels through the GOLDROP. I let the jar, I'll get about that full of the debris, then I'll dump it in the pan and we'll extract our mercury. What we do first is just kind of shake it around and get it fluidized and get the blob to kind of join together. Okay, now we'll start shaking off some of this debris here. And you can see it's all the bigger debris, all the dirt and sand are gone into the tailings. So we should start seeing a blob of mercury somewhere, kind of try to pop up. Shake it back down, we'll stir it again. There it is. So now we'll just kind of tip the pan to the side and let it drop out. And we'll go ahead and snuff it up here. There it is. So now we'll go ahead and settle the rest of this and see if there's another little blob in there. Sure enough, there's more mercury. We'll let that roll out of there. Collect that up. And there you have it. So far I've got, a little bit of mercury in that bottle there. We'll carry on here and see what we get. There it is. Roll that one out of there. Pick that one up. This is the final result of the mercury recovered from that clay dirt through the gold drop. There we have 37.1 grams recovered. Now, quick calculation, we'll figure out what our percentage of recovery is. We started out with 39.9. Wow, that's an incredible 93% recovery. That is incredible. Well, thanks for watching, and thanks for being interested.